All right, welcome to the last FRQ of 2017. Yes, it's a pretty rough FRQ season. Um, so this is a good one. When you take a look at it, you're like, oh man, there's a lot of info. Well, it isn't. There's three specific pieces of information they're giving you. They're giving you a function f, and they're giving you the f function as just a function. Then they're giving you a g function, and that's going to be as a table. And then they're giving you an h function, and that's going to be as a graph. So what they're going to be doing is asking you to find the derivatives, and they're going to have chain rules and product rules and all kinds of stuff like that for these three functions. And sometimes you're going to have to use the equation, sometimes use a table, sometimes you use the graph, but you have to know where f prime and g prime and h prime are on these three different representations of a function. So let's go ahead and break into it. Question A says, find the slope of the tangent line of the graph of f at x equals pi, which means I'm really going to look for f prime at pi. So if they give me a function like f of x is this, and I need to find f prime, I'm just going to find the derivative of it. So the derivative of cosine 2x is going to be, well, that's going to be negative, and it's going to be negative sine, but there's a 2x, so there's also going to be a chain rule in there. So it's going to be negative 2 sine of 2x plus, and then the derivative of e to the sine x is going to be e to the sine x times chain rule cosine x, which looks really gross, but I'm just plugging in a pi. So when I find f prime of pi, well, this is going to turn into 2 pi, right? So it's going to be minus 2 times, and the sine of 2 pi, that's just 0, plus e to the sine of pi, that's just 0. And the cosine of pi, that's just negative 1. So it looks like my final slope of my tangent line is just going to be a negative 1. So let's take a look at what the points were on this. This is a 2-point problem. Excuse me. Yes, it's a 2-point problem. Yeah, it is. 2, 4. 2 total points. You get 2 points if you got negative 1. So if you got the negative 1, you just found the derivative and plugged it in and got it, you get 2 straight points. Boom. You didn't get negative 1. Sorry about that. All right, part 2. Wasn't too bad. Part 2 says, hey, let's do the same thing with k. You're like, there's no k. I know, because k is going to be a composition of 2 functions. K is h of f of x, which means I'm going to have to be finding f prime of x again, except look at where it's at. It's at pi. We already found that it was negative 1. So if k of x is worth h of f of x, then k prime of x is going to be h prime of f of x times f prime of x. So now all I'm going to do is find k prime of pi, which means I need h prime of, I got to plug a pi into f of f. I got to find f of pi. So f of pi is going to equal cosine of 2 pi. Cosine of 2 pi is 1. And e to the sine of pi, is it sine of pi 0? E to 0 is 1. So f of pi is worth 2. So I need h prime of 2 times f prime of pi. Remember, we found f prime of pi right here. It was worth negative 1. So what is h prime at 2? All right, now I got to find h, which is h is over here. So h prime at 2 is right there. So what is the slope of the h graph at 2? It looks like it goes down 1 over 3. So it's minus 1/3 times the negative 1. It looks like my answer is going to be positive 1/3. So let's see how they distributed their points. So here we go. 2 points distributed in the problem. You get 1 point if you correctly wrote the chain rule. And then if you correctly evaluated it, that's how you get your second point. Cool. Next one. I haven't even looked at this one. I'm excited. All right, part C. It says, let M be defined by the following. And then it says, M of X is G of negative 2X's times H of X. Find M prime of 2, gross. So M of X, I'm going to do it down here, equals G of negative 2X times H of X. So we got a product rule, right? So we're going to have G prime of negative 2X, chain rule, times negative 2. That's the first part. So the derivative of the first times the second, plus the derivative of the second times the first. Right? So here is M of X. And then I'm supposed to evaluate M of X at 2. So I need M, sorry, this is M prime of X. So M prime of 2 is going to be G prime of, well, I'm plugging 2 for X, negative 4 times negative 2 times H of 2 plus H prime of 2 times G of negative 4. So I'm just plugging my 2's in. So I need G prime of negative 4. That should be in my table of values. There it is. So I need G prime of negative 4. So G prime of negative 4 is negative 1. So I'm going to write that one here. I need H of 2. So H of 2 is going to be gross. Is that at negative 2/3? Negative 2/3. I need H prime at 2. I already found H prime at 2. It was, no, that was the other one. H prime at 2. Yeah, I did. It was right here. It was negative 1/3. And then I need G of negative 4. And G of negative 4 is worth 5. So those are the values that I just got. I hope that I did those correctly. Here we go. I have negative, negative, negative. That's going to be a negative 4/3 plus a negative 5/3, which is going to be a total of negative 9/3, which is negative 3. Isn't that convenient? All right, let's see how they split up points. Here we go. 2 points for this one. Once again, you get a point for M prime. If you correctly wrote that big long expression, you get it. And if you found the value negative 3, you get the second point. That's pretty much how it's done. All right, last chunk. It says D, part D. Hold on, let me scooch down. Part D said, is there a number C? I'm like, hold up, a number C? Dude, I bet you I haven't even read this far. I bet you it's going to be mean value theorem or intermediate value theorem, one of those two. I bet you I know, because that's the only time they use C. So here we go. Is there a number C on the interval where G prime of C is negative 4, ladies and gentlemen? It is the mean value theorem because it says G prime, and mean value is the one with the slopes. So I need to find, is the average slope on this interval equal to negative 4? Because if the average slope is negative 4, according to the mean value theorem, then the single derivative or the instantaneous derivative has to be negative 4. And I already know that. I'm going to write mean value theorem because it says justify, no matter what I do. So here we go. I'm just jumping to their results over here because it's probably pretty straightforward. So here we go. What is the average slope? Remember, we learned the average slope. It was called M, and we learned it in Algebra 1. So I plug in. I look on my table. I find G of negative 3, and I subtract G of 5, and then on the bottom I do negative 3 minus 5, and I get a slope of negative 4. Imagine that. Imagine it has a slope of negative 4. You get a point for finding that. And then you have to state, therefore, according to the mean value theorem, there must be at least one C such that that is true. Done. The only thing I would warn you of is you might want to state that it is continuous and it is differentiable. Those are the things that have to happen for the mean value theorem to occur. But they did not require that, so I guess you're good. All right, later. 2017, good year, rough year.